All right, welcome to today's webinar on mainframe tape to cloud migration. I am Dustin Froyam, and I am one of the co-founders of VirtualZ. And today, co-presenting with me, I have Vince Ray, co-founder and CTO of VirtualZ. And so today we are going to go through a few different things on use cases and how you can do the tape cloud migration. All right, our agenda for today. So we'll do a little introduction, which we just did, and then understanding just this pattern, some of the benefits of moving from tape to cloud, or some of the challenges that people experience through legacy tape solutions, and then some use cases and how we actually solve those use cases. And then we'll have Q&A and conclusion. So let's first start with what the definition is. So, today you have the virtual tape libraries or actual physical magnetic tape. There are some emerging cloud solutions, but those are pretty point solutions and very, very different architectures than what we would recommend. But most of what you see out there in tape today is those virtual tape libraries and magnetic tape. So some of the challenges, those are high costs solutions. It takes a lot of capital expense to implement those. Tape is also subject to degradation over time. So that's a concern for those that have been using tape backup for a very long time. What do you do with those old tapes? Do you put them back onto VTL, or is there really a better way to do that? How do you scale some of those old systems in today's environment? You have to order them in advance, get them on the floor, pay to install them. Again, we think there's a better way to do that. And like I mentioned, there's some significant financial benefits to this, moving from CapEx to potentially OpEx expense. You reduce waste in this way as well. In my background, we saw a lot of capacity on demand, particularly in those virtual tape libraries that may or may not have gotten used. So that's expensive to the supplier, and ultimately the customer is paying for that. And so you have some operational inefficiencies as well. So again, the high cost, how do you order it and get it into your floor? So let's talk a little bit about the use cases here. And Vince, I'm going to ask you to help me out with this part of it, but let's talk about like the first one we see, which is one of the simpler patterns. So we have an application that is being replatformed. And so they want to deal with the legacy tape data. Obviously, they don't want to leave that behind and make that inaccessible. They need to make that data available to the replatformed or migrated application. So Vince, how do we address that one?
Yeah, so so first, thanks Dusty for the setup there. But generally when you're bringing that, maybe what had been a mainframe application to somewhere that's not on the mainframe, you're getting to that data that maybe happen to be tape data is one of the key challenges there. There are a few considerations here. If I'm moving an application to the cloud, I might be completely re-architecting it. I might be getting away from kind of traditional I/O, open, close, read, write, and I might be doing something more modern than that. I might be doing something like SQL queries against databases and so forth. So, one of the overarching questions is, what format do you want your data in that's going to be easiest for you to work with? If it's your goal to get that data into a database structure, that's kind of different than if your goal is to get, kind of retain, a big sequential file that you're going to process in the cloud. Our Propel solution can technically do it either way, but it is a key point for the customer to think about. The other thing that's really important is just the scale. what you do if you have, I don't know, handful of tapes is going to be really different than if you have tape libraries with thousands of tapes in them. Then you're looking to do a wholesale migration. Maybe your plan isn't just to migrate an application over the mainframe. Maybe you're looking to decommission the mainframe, and you want all of your data to end up in the cloud. So in that case, there's a challenge of how do we inventory and even find all of those data sets? And that kind of plays into it as well. Our Propel solution kind of fits that model really well because it's something that's very easily scripted. If we can find the tapes, and usually that really comes down to one of two things. We're either integrating with a tape management system, RMM, IBM's product, or Broadcom's, CA1 or TLMS, or whatever you happen to have, and getting the inventory of tape out of that, or else we're assuming that the files you want exist in the ZOS system catalog, and we can search for them and find them that way. So one way or another, we start out with this idea of, well, what are the sources? What tapes do we need to process? And then from ZOS, and let me be clear, Propels is an application that you run on ZOS. ZOS software, it can access and read just about any mainframe data set, including tape data sets, including things like GDGs, if that's important to you, and on and on and on that way. So we'll find all of that tape data, feed it through Propels, and what Propels is going to do is push that data to the cloud in really a variety of different formats. Most of the time, it's going to be a database format. So those records from your tape are ending up as blobs inside a database. And I'll come back to that in a second. There are cases where you want to do something more granular than that. Uh, on the other hand, if you don't really want to go to a database, if you did want to preserve the kind of file system structure of tape, just sequential files, you can do that as well. These are all options into Propels. Now, one of the other things I mentioned, data transformation. Uh, you can absolutely use Propels to not just store blobs in the cloud, but to transform that blob into kind of granular, rows and columns, if you will. And the way that works is you supply us with a little bit of metadata, and typically that's nothing more than a COBOL copybook or really anything similar to that, and we'll use the information in that to understand the records that are being moved through Propels. So instead of just saying, okay, here's record number one, and inside that record might be 100 different fields, we understand all of the fields. So you would see in your target database whatever those fields are as individual columns in the database, and that makes it much easier for your applications to process this data. Uh, and again, the target could be anything. It could be MySQL. It could be Oracle database. It could be Microsoft SQL Server. There are about 100 different database targets that we can support that way. And of course, some organizations might even go to multiple of these concurrently. Different tapes going to different targets. That's absolutely possible with Propels. The other thing too, while we're talking about the data transformation, if I'm not going to a database, I might want to take those records that started out on tape and not just store them bit for bit the same as they were on the tape. You can do that if you want, but you might want to transform them into let's say XML or JSON objects, or something that's a little easier for non-mainframe software to deal with. So when you're going to other than databases, you have again, really the sky's the limit. You might, if it's, let's say backup data and your intent is to move it to the cloud, but, it's not the kind of thing that you're intending to process heavily. I mean, you might choose something like Amazon Glacier, something really low cost, designed for long-term storage, easy to replicate. So, and I mean, Dusty was talking about the cost and expense of virtual tape. One of the particular problems with that environment is if you want fault tolerance and you have multiple virtual tape library systems, you end up with a pretty expensive communication network and multiple bits of hardware in different locations. Let the cloud provider do that. Put one copy in Amazon and one in Azure if that's what you want to do, or just tell AWS that when I store data here, I want it replicated in two different data centers, and that's not your problem anymore. So the savings are potentially very, very, very large there. Now I want to be just to close off this section of it, I want to be clear when we're talking propels. This is I think of it as a one-way solution. In other words, this is the use case where I move my application to God knows what platform. I need the data, and I'm not really intending on processing that data from the mainframe anymore. This is I migrated. Whether I just move that application or whether I intend to decommission my mainframe one way or another, I really don't have real-time need to go back and process that data over and over again. This is more just an enabler to get my data into the cloud where other applications can process it. So Dusty, would I miss any parts I should clarify?
No, I think you covered it. I just want to confirm. So Vince, one option is you store it in a blob, and I think that was a pattern we've had quite frequently with Rocket Enterprise Server customers, right? Replatforming, recompiling that application, but then wanting to have that data accessible in the cloud. And then the other one is to transform it, put it into rows and columns in a data lake. Now that could be to a refactored application, or even made available for AI and BI purposes as well. Is that right, Vince? Do I have those two patterns down?
Yeah, no, exactly right. If you transform it and kind of decompose that data down into rows and columns, it's much, much easier to use by really any application that can, just understand database queries. So, I mean, AI and the things you mentioned are great for that. But I might want to just bring that data right into let's say a reporting tool like I don't know, Tableau, or whatever your favorite BI tool is. All of them will be able to understand that data at a field by field basis, because it's just database rows and columns like any other would be. So yeah, and by the way, it's also as you said, it could be data lakes. It could be something like Snowflake or Databricks, could be Mongo, could be really, really the sky's the limit there.
Yeah, and I showed that one graphic, I think, when you were talking a little bit about that pattern. I was just going to mention one other thing. So in regards to the architecture, Propels is a mainframe only product, so you don't have to run any code on the cloud side. And it's also zip eligible workload. So not only do you get the savings from the storage side, right, from your legacy physical tape or VTL, just the MIPS we use to do the work to transform, to move that data, is also zip eligible.
Yeah, and that's really an important point in this case, especially if you're doing a large scale operation, because you might have, I don't know how many terabytes or petabytes of data you're looking to move. So this could be a very long running task that would otherwise be quite expensive to host on your mainframe. So the zip eligibility is really important in that case. It means that you can run as much propels as you want, and it's really not going to impact your software bills because of the utilization there.
And just one last thing on Propels, and I know this isn't very, it's really targeted towards the database, but it gives you an idea of the performance. Vince, could you just talk a little bit about the performance we see with Propels as well?
Yeah, and I mean, that's an important part of it. When we're talking about the kind of migrations we're dealing with here, a lot really comes down to how long does it take and how practical is it because of performance concerns. Nobody wants to, let's say generate reports, but it takes a month to move the data from your mainframe to the cloud. So, let me just put some numbers to it. In our test environment, and you understand that our environment is as small as it gets from a mainframe point of view. We run on the smallest possible ZOS system. It's under 100 MIPS. And we're connected to the cloud with nothing more than kind of a consumer grade, gigabit connection, nothing fancy or high end there. And yet, even in that configuration, we have no trouble getting, about 6,000 rows per second for most of our tests. And that's with large and complicated records. That's with records that are, not just 80 bytes long. Or what we test with tends to be, about 1,000-byte records with lots of different fields that are decomposed into their native types. So, our expectation is, we put this in a large mainframe site where there might be, let's say even multiple, high bandwidth pipes to the cloud. We would expect probably, at least 10 times the throughput that we're seeing. Now, all of a sudden, gigabytes or easy terabytes or, maybe, half an hour kind of operations. And suddenly, what we're talking about here is, eminently practical. So, at the core architecture level, the reason for that is that, unlike some of the competing technologies here, we're not based on HTTP and text-based protocols. We're based on, very efficient binary protocols that are really designed to move large amounts of file system data across a network. So, we feel pretty confident that, there's no magic in the universe. If you have a cellular connection to the cloud and that's it, and you're trying to move hundreds of terabytes over it, that's going to take a while. But we think that, compared to most alternatives, we should outperform most things that are out there.
Okay, thanks, Vince. I'll just mention, so the Propels is an extremely economical solution. So the license part of it is just $50,000 per year, unlimited data, unlimited installs. There's no catches to that. It's just basically a $50,000 enterprise license. And there's many other use cases for Propels as well. We'll be glad to talk about those. And then, discovery and scripting is, a pretty nominal services charged to do that from us directly. And then we have a number of really great partners in this space that can help out as well. So it can really be a turnkey migration solution if you're kind of taking that one-way trip. But if you're not taking that one-way trip, so Vince, I'm going to ask you about kind of just, you're keeping the mainframe. This is really tape or disk backup on the mainframe, but you want to get away from VTL and physical magnetic tape. Can you just tell us a little bit about how we go about this and our solution for that?
Yeah, so this is our Zaac product, and Zaac is also software that you install on your mainframe. And what it does is it creates what I'm going to call a virtualization of a tape device. So your mainframe applications continue to see what they perceive as just standard tape devices. When they access those devices, do I/O to them, instead of that data going to a physical tape someplace, it goes through Zaac, and then Zaac does much of what I described under Propels. It uh, allows that storage to be backed by cloud storage or by even by physical storage that might be in your own data center, but on a low cost, let's say a SAN environment. So, Zaac gives us that ability to really look just like any other tape device would look, but instead of physical tape or a virtual tape library or really any of that class of hardware, what you've got is a software implementation of a tape device that backs its storage with whatever cloud providers you want to use. Uh, Similar to Propels, I mean, the technical details are a little bit different, but similar to Propels, that back end is kind of open. It's a standard that we implement that allows us to support really any type of cloud storage out there. Out of the box, we supply the big three, Amazon, AWS, Microsoft Azure, and Google. But it's an open standard that can support really anything. So if you decided, I don't know, you wanted to use Dropbox for your tape storage, you absolutely could do that. It also supports physical SAN. So if you had a big SAN investment that you're using for all your platforms except the mainframe, suddenly you can use that same environment for mainframe devices. And by the way, I'll just quickly mention that's true for both tape and disk. What I described for tape migration works exactly the same way for virtualizing mainframe disks. So if I have enormous amount of SAN storage and I want to carve some of that out and use it on my mainframe for virtual mainframe disks, create VSAM files or DB2 databases or any other type of mainframe storage, I can do the same thing there. It's one copy of Zaac, supports both virtual disk and virtual tape. For migration, the path would be, very similar to what I described with Propels. We'd one way or another hunt down all the existing tapes, migrate them through Zaac, and at the end of that process, the data would be in whatever target you wanted. Let's say S3. Uh, Unlike Propels, though, it's a bi-directional thing. Once that data is in the cloud, you can still run your mainframe applications. They can still reference the same tapes they've always referenced, and that data would be accessible to them from mainframe applications and really from anywhere that has access to that, whatever your target environment is, to your S3 account or whatever that happens to be. So, much more real time, much more designed around the idea that you operate your mainframe in an ongoing way. And it's just you replaced your physical tape, virtual tape libraries, all of that infrastructure with something that can be much, much, much lower cost than that. Zaac can also be, I mentioned under Propels that fault tolerance is important to a lot of sites. Zaac can be configured that way too. So, Zaac can be configured to duplex. So I might have exactly what I mentioned before. I might have one copy of my data in the Amazon cloud, another copy in the Azure cloud. Maybe I have a copy in my own data center 10 feet away from my mainframe on my SAN, and then another copy sitting in the cloud someplace. So, it's kind of a different way to think about achieving fault tolerance. The data duplexing is low cost enough that you can kind of shield yourself from potential outages here in lots of ways that are just really hard to do in any other way. So Dusty, what did I skip over that I should have mentioned?
Yeah, well, we've got a couple questions I'm going to ask you now that were pre-submitted, and I'm also going to ask you a couple of my own. So, Vince, what do we do about reducing latency, like trying to approach a 0 second, recovery point objective? Can you talk about how we address that?
Yeah, so a couple of things there. One is that this is probably more critical to a customer using the cloud for virtual disk than he would for virtual tape. But one of the kind of patented features in Zaac is this idea that we do local ZOS specific write caching and journaling. So let's say I write a block to a tape. Most applications, if you're writing to tape, you probably really care about that data. You want to guarantee that it's been hardened to the tape before your I/O is marked complete. You don't want us to take that data, tell you that it's complete, and then you keep chugging along creating more data, and then we find out after the fact a network outage or an error in the cloud provider stopped the data from getting there. So what we do instead is we use some built-in ZOS components, sync components that things like DB2 use, and we store a local copy of that data on ZOS using the system logger, as you see in the diagram here. And what that means is as soon as we're certain that that data has been hardened locally on ZOS, we can tell you that your I/O is complete, even though the physical update in the cloud may not have happened yet. It doesn't matter at that point if there's a network outage, we have your data. The data is, that system logger component could be keeping a copy in the coupling facility, on disk. It could be, in many places hardened away there. So, we're pretty much able to, once we're sure that data has been committed through system logger, we can, mark your I/O complete, let you kind of keep chugging along, doing whatever you need to do. And what that does is it speeds up the I/O processing, especially on the write side, by a factor of maybe 10. So you get very close to native channel performance, even though you're dealing with cloud storage that has a network in between the mainframe and wherever that storage might be. The other thing that's really interesting to us is that many of the customers we speak to are very interested in doing more of the SAN model than the cloud model. For a lot of reasons. They may have what Dusty mentioned before. They may have overinvested in that. Now they have all kinds of storage that they'd like to use, but they don't really have a great use for it. They'd like to repurpose some of that and take advantage of it in the mainframe. Now, in that case, I mean, it's still technically a network. It's still connected over, a TCP/IP connection, but it's not, a long distance network. Like, as I said, it might be 10 feet away from your mainframe. And some of the devices that we're starting to test that with are showing us amazing throughput. Tens of thousands of IOs per second on devices that cost just a few $1,000s. So, that's a whole set of options too. And the fact that, even if that's not your ultimate goal, but you want to use something like that as a local, almost a cache for what you do in the cloud. So you duplex it, writes to that local, iSCSI capable device first, and then to the cloud second. I mean, that's yet another way to optimize the bandwidth here. And as I said, uh, with Propels, the protocols here are generally designed for lots of data movement. It's not like we take something that really belongs in your browser and we try to extend it and do massive file system activity with it. We use things that are really designed and have evolved over a long period of time to be as efficient as possible when dealing with all kinds of data this way. So I think we feel actually pretty good about the performance potential here. We think that assuming many of you would be large mainframe customers, have already been down this path. I mean, you're using what I'm talking about on other platforms. People do this with Windows and Linux and other platforms all the time. So you probably got a lot of familiarity with this. What we're doing is enabling you to leverage that infrastructure that you've already built from mainframe applications, and that's really the key there.
Okay, Vince, I'm gonna ask the couple of pre-submitted questions. I'm gonna answer them in my head while you answer, and hopefully I get them right. So, how is robotic tape retrieved handled?
Yeah, so robotic tape libraries are kind of an example of what I talked about under Propels, where a lot of the challenge is just knowing what kind of inventory of tape that you've got. Where are the data sets is one of the first questions that we ask here. And as I outlined, that's probably a little different depending on what your environment does. But typically, that's just going to be a matter of go find those data sets either through the system catalog or through the tape management software, and we can support either. And that gives us the inventory. Okay, so this robotic tape system has all of these tapes in it. Now we can fetch them, stage them, and migrate them. So it's really an issue of that implementation phase where you're thinking about getting your data out of the old environment and into the new environment. With Zaac, if you're doing virtual tape, you generally don't need that anymore. You generally don't have that paradigm of gee, let me send a mount request to this foreign thing and it'll stage my data where I can get to it. With Zaac, you just access what you think is a local tape drive, and all the rest happens automatically. It's all available to you concurrently. There isn't that need for, oh, let me go pull the cartridge out of the robotic system, put it on a device somewhere. Now you can access it. All of that goes away. And again, that has some very interesting performance implications because many times customers will tell us that a very busy robotic tape system gets to be a bottleneck in large organizations. If it's got, it's only got a certain number of actuators, it's only got the ability to process a certain number of requests over time. So if you need to do lots of concurrent processing, that can really slow things down. So that time from when the application starts and tries to mount its tape volume to the point where it gets its first record to process can be very long in a robotic system. In our system, we don't care about any of that. There's nothing physical here. It's just, connect to wherever the data is hosted, and you're basically instantly accessing that initial tape record. So, a lot of that overhead of dealing with the tape library just disappears with with the Zaac approach. If you wanted, as part of your Zaac deployment, you would essentially tell us how many virtual tape devices you want emulated. Could be 2, could be 256. There's no technical limit. It's just a matter of what you think your concurrency needs are. And then within that, let's say you say, give me 256 tape devices. You could allocate, open, read, write, whatever you want, all of them in parallel. And, certainly that'll generate a good load on on the network between your site and wherever the cloud provider is. But it is all happening in parallel.
All right,
Good,
thanks,
good,
Vince. So the next
good
question,
question. We should
yeah,
remember that, Dusty. That's a good
yeah,
question.
exactly, yeah. I haven't talked about the robots to this point, so yeah, that is a good one. Okay, so once the tape is migrated to the cloud and the tape hardware is decommissioned, how can the data on the tape be accessed if needed? And I think we've partially covered this, but I think let's answer it again, Vince. Does the solution include any tape emulation technology to enable? And I guess there's probably two different patterns here, right? One is you've completely retired the mainframe, and two, that you still have the mainframe and you're using Zaac still, right? So I guess we can answer it in both contexts.
Yeah, yeah, and that's exactly right. In the case of Propels, as we explained, that's a one-time operation. You're taking the state of your tape data and pushing it to the cloud. And the expectation is the application is a cloud application. And whatever it's using, it's probably doing SQL processing or whatever it's doing. It has access to that data now because it's in the cloud that way. That's kind of one answer. And by the way, if you wanted to update that data, I guess technically you could. It's just database rows and columns. You would do it using the facilities of whatever target you ended up with. So if you put it on an Oracle database, absolutely you could update it by sending Oracle database queries to that environment. That's up to kind of the needs of the application that way. But if you went back and, let's say rewrote that tape with different data on it, you would basically run Propels again to push that data to the cloud again if you had some need to do that. So that's kind of incremental approach as we're talking here. The Zaac answer is the truly real-time one. When you complete the migration in the case of Zaac, you still have, what the application sees as same access to that data it always had. So, if that application wants to come along, access that tape device, read a handful of records, write a handful of records, whatever it wants to do with that tape volume, it absolutely just continues to work completely unchanged right from ZOS that way. So and I would say that's really a good distinguishing feature between Propels and Zaac. If you're envisioning, I'm going to call it an active thing. In other words, I'm accessing that data and I'm accessing it from my mainframe applications. In fact, I may not even have any cloud applications. I may just be migrating that data as a cost saving measure. I'm looking to retire all of that virtual tape hardware and software and all of that stuff, and I want to replace it with something less costly than that. Zaac is the answer to that. It gives you what you still access just like any other tape, even though it's backed by cloud storage. So Zaac is you don't need anything different than that. There's no proprietary API. There's nothing like just access the tape like you normally would. Propels is put the tape on whatever target you want, and then use that target's APIs or interfaces or whatever it provides to manipulate the data once it's there. Does that make sense to you, Dusty?
Yeah, it does. I'm going to throw you for a curveball though. So Vince, let's say the customer is just storing the legacy tape data as a blob with Propels, right? They've moved it. Would they be able to retrieve that blob, that file, with the same retrieval utility we're using for like SMF storage or DB2 log storage? Is that possible for that customer? Let's say they are maintaining their mainframe, but they just want a simple storage solution in blob.
Yeah, so one of one of the things that we include in some of our other solutions is a way to go back to that provider wherever Propel's wrote and query that data, bring it back into ZOS, and write it out to a traditional ZOS file. So if you wanted to fetch that data, store it on disk, or recreate a tape, or whatever you need to do with it, you absolutely could do it that way. And what you'll end up with is bit for bit equivalent to what was on that original source, whether tape disk doesn't really matter, on the original source that went into Propels that way. The other advantage of that whole approach is when we're storing the data as blobs, one of the things that we're also including in that target is things like the record numbers and timestamps, and some other control information. So what that means is you don't necessarily have to say, go give me this terabyte long tape. You can say, just go get me the first 100 records of it, or get me all the records that were added since such and such a time. And we can do kind of a selective query and give you a subset of that data. So much more flexible. It's not an all or nothing. Here was the tape volume I started with, and now I can recreate it. You could do that, but you can also be pretty flexible about what portion of the data that you want.
Very good. All right. Are there any other questions? Either raise your hand or submit through chat. Well, we must have done a brilliant job, Vince.
Yeah,
Okay.
we put everyone to sleep. I hope
Yeah,
that's
exactly.
not.
Yeah, exactly. All right, I'll come back one more time and ask if any questions. So let's just kind of review some of the benefits here. So we've talked a lot about the cost savings, right? You go from a capital expense or even financing through, our friends at like X financing services, right? Which increases the cost or reduces the margin to a certain extent to the vendor, usually cost to the customer, as we all know. Really convert that to OpEx, right? Especially if you're using something like Glacier, fractions of a penny per gigabyte, and that's a really compelling situation. So just eliminating all that upfront cost, and then obviously the scalability that comes along with that, really on demand, or it's really software defined storage for the mainframe. Just deciding where your target is, duplexing, etc. You have increased efficiency, like we were just talking about with the scalability, and then the business agility that comes with that. You don't have to do all that laborious capacity planning for your storage. You can just kind of do it on demand, and then pay as you go or pay for what you consume. And obviously the improved resiliency is really important, especially in today's day and age, with application data backup and recovery, ransomware, having you could have multiple immutable copies to those different targets. So even if you lost one cloud, you could have the other cloud back it up, or as Vince kind of went through the architecture, having it on-prem with SAN as well. So there creates a lot of efficiencies and resiliency there as well. And then, getting to your data in a different manner, right? If you do want to share that data, you don't have to, right? You can let the mainframe control that data, particularly in the scenario of Zaac, or you can share it because now you've been able to, inline, no code, convert it to a data lake, database, data warehouse. Okay. So is there any other questions that came up? And I see we just had someone join. This will be available on replay. So yeah, love to have you just join us on a replay, or, we're always open to a one-on-one briefing and discussion as well. So just reach out to us. We're glad to do that. We can repeat the whole thing if needed. So we're happy to do that. Oh,
Hey,
I,
Dusty,
I, I
I
see
see
Mark
a
Combs
hand.
has a question. That could be dangerous, Vince.
Yeah.
Let's see. I don't know. Oops. I don't know if I know how to answer his question. Jeannie, you might have to do the answering.
Okay, I'm here. Is the question in the chat? Let me just look.
Yeah, it's Mark. Oh, Mark, it looks like maybe your microphone's live. Try us, Mark.
The question I have, Dusty, from Mark is, can you please talk about how the Zaac tape approach works with tape library control systems?
Oh. So like CA1.
Yeah, so generally, the tape library is doing a handful of things for you. And probably the most critical one is keeping track of what's a scratch tape. In other words, what you can write to and what you can't write to. That doesn't go away. We are not trying to replace that kind of logic with what we do in Zaac. We maintain the library. You create a 1,000-volume tape library. Absolutely, we can do that. But tape 626 being in scratch status or not, that's up to the tape library system. So, and generally, whether that's CA1 or TLMS or RMM or whatever else you might have, that would continue to work the same exact way. There's no real functional difference there. The tape management products understand that they're working with what they would see as a physical tape device, and they behave exactly as they would today. So there's no migration of that. One of the challenges with some of the competing technology here is you have to think about all the complicated expiration rules and everything else that goes into your tape management product. How do you migrate that to some new type of system? With Zaac, you don't have any of that. It just continues to work, exactly as it works today. When one unique piece of that is when when an application might call for a scratch tape. In other words, just give me, I don't care what tape you give me, just give me something I'm allowed to write to. Zaac wouldn't necessarily know how to pick a usable scratch volume in that case. So we provide an integration to the tape management system. The tape management system can come back to us and say, here's a tape that's usable, and that's what we'll do. So all of the logic for managing the scratch tapes and knowing when to expire things, and even things like, I don't know, stacking multiple data sets on an individual tape. I mean, that all continues to work using the facilities of the tape management system. And we have no real intent to replace that with something that we try to take over, mostly because it is such a difficult transition if you have to bring all of those records and rules and everything else across into our software. Yeah, that's a good question too.
Yeah, I think that's a really important architectural difference, and I'll just reiterate that. So again, Zaac is mainframe only. It's driver based. There's no code required in the cloud. So you don't have to have cloud software running and an agent and go through that risky migration. In this case, it is really just replacing your storage and you can keep your processes and some of your other systems intact. And so again, that gives you the benefits of the duplexing and the journaling and some, safety and security features that, aren't necessarily readily available in some alternative approaches here. Okay, last call for any last questions. I don't see any. And yeah, Chris, great. We'll be happy to be happy to provide the recording and follow up as well. Otherwise, thank you for joining us. I know we went a little over time, but it was a great discussion, and we have a lot of other resources available, blogs, demos on demand. All of our products are available for free trial as well. So if that's of interest, we have a podcast. So we have a lot of information, and just one more webinar before the end of the year in this series, and we're going to talk about mainframe management data. So SMF data, both for observability, archiving, console messages, DB2 logs. We'll get into all of that and how we can efficiently help with that. And some of it's just storage. We've had a number of customers that just says, hey, this is taking up a lot of mainframe native storage. How do we just get this to be archived off of the mainframe, but still retrievable, searchable? So we'll go through that pattern as well. Okay, thank you and have a great rest of your day.